Welcome to the first video of the Foundational Mathematics Concept Primer Series. These videos are intended to be watched before lecture as an introduction and overview of the concepts. They are not intended to replace the lectures. Section 1.1, the number line. The number line is a picture that we use to represent numbers in order. As we move to the right, the numbers get larger, and as we move to the left, the numbers get smaller. There are several uses for the number line, and we will see these as we move forward. The first application of the number line is to assist with addition. Example, compute 5 plus 6 on the number line. In order to do addition on the number line, we start at 0, and then we move to the right the number of spaces corresponding to the problem. In this case, for 5 plus 6, we first move 5 spaces to the right. 1, 2, 3, 4, 5. And then we move 6 more spaces to the right from there. 1, 2, 3, 4, 5, 6. We can see that we've stopped at 11, so 5 plus 6 equals 11. The scale of the number line that we use depends on the problem that we're working on. In the previous problem, we used step sizes of 1, but we can use step sizes of anything else that's convenient. For example, we can use step sizes of 5, or even some unusual numbers like step sizes of 3. Example, compute 15 plus 35 on the number line. If we were to try to do this calculation by using a number line with step sizes of 1, it would take us a very long time to actually get to 15, and then to get 35 beyond there. Hopefully you can see intuitively that 5 works well with both 15 and 35. We'll later see that this number 5 is known as the greatest common factor of 15 and 35, but that's not important right now. We will use a number line with step sizes of 5. As always, we start from 0. We go 15 spaces to the right. Now every time we go to the right one step, that counts as 5. 5, 10, 15. And then 35 more. 5, 10, 15, 20, 25, 30, 35. We ended up at the number 50. And so we have 15 plus 35 equals 50. One-step addition. One-step addition are the simplest addition problems that we have in this class. For this class, we're going to trust that you already know your basic addition tables. Example, compute 12 plus 6. The idea here is the same as before. We start at 0. We move 12 spaces to the right, and then 6 more, and try to determine where we're located. Using our previous experience with numbers, it should not be hard to see that 12 plus 6 is equal to 18. We're going to do these calculations without having to draw the number line every single time, but we need to keep the number line in the back of our minds because it will become useful later. Example, compute 29 plus 8. 29 plus 8 is equal to 37. When you see this calculation, you want to get away from thinking about carrying the 1. Carrying the 1 is a somewhat artificial thing that we do when we teach students how to add in columns. If we think about the number line again, here's 29. If we go one step to the right, we get to 30. And when we get to 30, we shouldn't have to think about that as 9 plus 1 is 10, carry the 1, 1 plus 2 is 3. We should just be able to say 29, and after 29 comes 30. Being able to develop some numerical intuition like this will make calculations simpler in the future. Example, compute 16 plus 40. 16 plus 40 is equal to 56. For this class, we're going to assume that you understand the basics of the place value system. If you don't, talk to your instructor. Notice the presentation of all these problems. You start with the original problem, an equal sign, and then the answer, moving left to right. We will not be adding in columns in this class. Section 1.3, Two-Step Addition. This section is more about habits of thought and habits of writing than it is about learning more about arithmetic. When we have a number, we can break it into parts by its place value. 54 is equal to 50 plus 4. This is a useful concept to have when doing arithmetic because we can take a number and break it down into pieces that are simpler to work with. Example, compute 35 plus 57. Now again, you can think of this on the number line, starting from 0, moving 35 to the right, and then moving 57 to the right. And our task here is to break this down into simpler pieces. Instead of thinking about 57 to the right, we're going to do it in 2 steps. We're going to think of it as going 50 to the right, and then 7 to the right. And by doing this, we make each calculation simpler. 35 plus 57 equals 35 plus 50 plus 7. 35 plus 50 is 85, and we still have to add the 7. 85 plus 7 is equal to 92. Notice the presentation of this calculation. We start off with the original problem, an equal sign, and then our first manipulation. From there, we keep our equal signs lined up vertically going down the page, and we try to keep every line neatly written. Section 1.4, Mental Addition. Once you have some experience with the two-step addition problems, you begin to train your brain to think differently. And once you've accomplished that, you can do more with less effort. Example, compute 23 plus 74 mentally. The way you want to be able to think about this is 23 plus 74 is 23 plus 70 plus 4. 23 plus 70 is 93. 93 plus 4 is 97. Example, compute 35 plus 28 mentally. 35 plus 28 is 35 plus 20 plus 8. 35 plus 20 is 55. 55 plus 8 is 63. Notice that when we did the calculation this way, we did not need to worry about carrying the 1. The act of carrying the 1 happened naturally from our experience with numbers. As you get better at this type of calculation, you gain the ability to do even larger calculations in your head. Example, compute 362 plus 475 mentally. 362 plus 475. 362 plus 400 is 762. 762 plus 70 is 832. 832 plus 5 is 837. At this point in the class, don't worry if this is not natural for you. You're retraining your brain to do something differently, and that's going to take time, practice, and effort.